Dear students, welcome to our class on JRF SRF NET 2022 Agricultural Meteorology Advances 9. So in this class, we try to understand what are the basic questions that would appear in the aero or dynamics. Aerodynamics is a very vast subject, but from agricultural meteorological point of view, particularly micro meteorological point of view, certain basic terms you should know. So in the SRF, particularly in the SRF, the most likely bits are like this. Okay, so those bits only I have prepared some bits. Those bits only may come in the SRF in the bit forms, even in the write up or even in the interviews you may be asked. Now see, in the atmosphere is a colorless, odorless and tasteless physical mixture of gases enveloping the earth on all sides. So physical mixture of, please underline that word, gases. Okay, what is air? The gaseous molecules, we call it as air. Okay, once again for your academic interest, atmosphere is defined as a colorless, odorless and tasteless physical mixture of gases enveloping the earth on all sides. Now, so gases have molecules. So the gaseous molecules, we call it as the air. Okay, air in its horizontal motion, we call it as the wind. Air in its vertical motion, we call it as the air currents. So these are the basics that form the terms related to aerodynamics. Once we try to understand aerodynamics, the first term is the eddy, E-D-D-Y. Now, okay, actually, before we talk about the eddy, the gases mixture in the atmosphere is air. That much you please remember. Now, what is eddy? What is eddy? See, usually the gaseous molecules transmit or transfer or flux. Okay, transmits or transfer their flux, whether particularly but moment of flux. Let us talk about moment of flux. The momentum flux is defined through gaseous molecules. That means, the gases will take the energy and then the flux gradient, say in terms of Newton's law of viscosity. So from one height to another height, the gas molecules move. So there is a gradient of velocity, in other words. Okay, now in case of diffusion, Fick's law of diffusion, from higher concentration to lower concentration, the molecules move. Okay, so from a water body is there, like a tank, like a small lake. From there, the flux of water vapor entering into the atmosphere. So that's what Fick's law. Now, the Fourier's law of diffusion. So what is Fourier's law of diffusion? So sun's energy is coming, it is falling on the cropped field, for example, or a bare field, or there is a cropped field, there is a bare field. Now the flux of energy entering into the different layers of the soil or different layers in the crop, we call it as the heat flux, explained in terms of by Fourier's law. Okay, like now here the gaseous molecules convey or transfer or flux energy, momentum particularly, all these things. Okay, good. So all these fluxes, they are they are most common in the agricultural meteorology. So they are gaseous molecules. What is eddy? Eddy here is a new packet, like a parcel, like a new entity which moves from one layer to other layer. So what is meant by entity? Say for example, water is moving. There is a swirl. Okay, there is a swirl. That swirl is in this layer. when it goes to other layer on its move, it loses its characteristics and then it merges with the main flow. Okay, so this particular spiral we call it as the eddy. Similarly, in the cyclones and anticyclones, there are eddies. Okay, in the cyclone, eddies are okay. They transfer from one layer to other layer, from one region to other region, because it's a big system like that. They are the eddies. Here, the most commonly find bits are okay. What is eddy? I just give some 2 or 3 important lines of eddy. EDD by eddy. Any disturbance, like a cyclone, like a spiral, or where I am standing in front of you now. See, where I am standing is close to the ground. It is really less denser as compared to, say, few meters above me. From here, okay, vertically, the eddies will take the energy. Because it is relatively warm, eddies will vertically take the energy. Now, it is a disturbance. Where I am standing in this class is a disturbing, because there is a lot of sun's energy. Okay, so it gets mixed, air gets less dense and it moves. Which moves? Eddies move. So that is a disturbance. Now, any disturbance, deviation or fluctuation of a fluid from the main state of a turbulent fluid flow is called eddy. Now, a translating or rotating air parcel is known as eddy. A translating or rotating air parcel, not air molecule. If we talk of molecules, it is air. Okay. If you talk of air parcel, that is eddy. It is a new entity. Okay. Basic characteristic of eddy is it retains its characteristics for some time before entering into the next layer. Once it enters into the layer, it loses its characters, mixes with the other layer, and then it attains the properties of the other layer. That's what. Okay, now, so a translating or a rotating air parcel is known as eddy. The transient eddies move in space. While standing eddies remain in fairly fixed locations. What are transient eddies? Transient eddies you find in the cyclones, and stationary eddies you find in the anticyclones. Okay, so these are the things. Now, eddy flux, radiant flux, heat flux, like that. Eddy flux is there. What is the flux? Flow. Eddy flow. Now, the rate of transport or flux of a fluid property by eddies is known as eddy flux. Once again, I read for your academic interest. The rate of transport or flux of a fluid property by eddies. Fluid means, there are two fluids, air and water. If it is a swirl, it transfers its energy. It goes from one layer to other layer, then it loses its characteristics of rotating structure, what we call it as in English terms, anything you call it as. Okay, now, an eddy is a movement. An eddy is a movement in water or in air, which goes around and around instead of flowing in one continuous direction. So, to move round and round or to move in a disorganized way, that's what we call it as the eddy flux, movement. Flux means flow. Now, so what is eddy? Diffusivity. Eddy diffusivity. What is thermal diffusivity? The ability to transmit, the ability to flow is called as heat diffusivity. Okay. Now, eddy diffusivity is also same. What is it? The exchange coefficient for diffusion of a conservative property by eddies in a turbulent flow of fluid is known as eddy diffusivity. Once again, for your academic interest, I read the exchange coefficient for diffusion of a conservative property. What is a conservative property? A whirling is a conservative property. It has its own conservation. with reference to whirling. Okay, that whirling around, round and round by eddies in a turbulent flow of fluid. So it distributes, it disperses into ordinary fluid. That round and round, okay, is conveyed into a laminar flow like. So that's what we call it as the eddy diffusivity, like thermal diffusivity. If I am standing on a thermocol, I won't find much hot. If I am standing on an iron rod, okay, ground is hot, iron hot is rod, I feel it uncomfortable. So the diffusivity of thermocol is less as compared to the thermal diffusivity of iron rod. So like eddies also, they exchange, okay, they exchange energy, and then it loses its property and mixes. Now, so what is eddying? E-D-D-Y-I-N-G. What is eddying? Now I will tell. This is the product of turbulence. This is the product of turbulence. A mass of air like a small whirlpool retains its identity and size for varying short periods and moves forward horizontally with the velocity of the wind. This occurs only because of eddying. E-D-D-Y-I-N-G. Small swirling wind is there, dust is there, some papers, some dust, okay, moving, just for a minute or two, they disappear. Why they disappear? The characteristics of that eddy is nothing before the air that is around. What is air? Gaseous molecules. So the eddy, now swirling wind, loses its identity while it is moving from here to say 100 meters or 200 meters. Like a cyclone for 2 to 3 days. Eddies lose their identity and then they mix with the troposphere. That's it. Now, so eddy viscosity, another term, eddy viscosity. Simplest, what is viscosity? Viscosity is the resistance to flow. Here also same, when eddies show some resistance, we call it as the eddy viscosity. In your bit terms, from your bits point of view, it is like the property of a fluid whereby it tends to resist. The property of a fluid which tends to resist the relative motion within itself. Wind is going and then it has got some property to resist itself. So it is called as the eddy viscosity. Okay, now these are the basic terms. There is another term which we have already discussed from the bits point of view. Frictional velocity also you should know. Frictional velocity is defined as the square root of the turbulent horizontal wind stress in the surface boundary layer divided by the air density in the surface layer. If you take the surface layer, there are two things. First, the density of the air is there, and the turbulent horizontal wind stress. Is there. So it is the square root of turbulent horizontal wind stress divided by the air density, we call it as the frictional velocity. Now there are two terms which we discussed several times, but from the point of your exam, these two terms are very important. Please listen very carefully. First one is the roughness parameter. Roughness, ROUGHNESS, roughness parameter. It is in civil engineering, in fluid mechanics, in aerodynamics of aeroplanes and everything. So the roughness parameter is indicated by Z0, roughness parameter. Now, there is another term called as zero plane displacement, ZERO displacement. So zero plane displacement, either in civil engineering, in the construction of the buildings, or you can say aerodynamics. This is an aerodynamic. Both are aerodynamic terms. Roughness parameter and zero plane displacement are aerodynamic parameters or aerodynamic coefficients or aerodynamic dimensionless numbers, in other words, in certain cases. Zero plane displacement can be estimated empirically, it is derived. The reference parameter are they are reference parameter numbers are they are constants, with dimensionless constants. So, say for example, the roughness parameter, please note this bit will come, the roughness parameter. Okay, roughness parameter means, let me define first. See, the surface offers some resistance by virtue of its topography, by virtue of its relief features, that means ups and downs. So for the movement of the wind, the surface offers some sort of resistance. That's what we call it the roughness parameter. That is the basis for eddies. That is the basis for eddies. It is the basis. Now, roughness zero plane displacement. Zero plane displacement is D. So the zero plane displacement is 6 to 20 times. 6 to 1, 2, 3, 4, 5, 6. 6 to 20. 20 times more than the roughness parameter in general. It may be. Both are given in meters. 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 Universally meters. Now, here, what is a roughness parameter? What is a zero plane displacement? From your examination point of view, I read zero plane displacement. This is the height, usually in meters, at which the turbulent exchange is assumed to start in an uniform crop canopy or tall vegetation. What is zero plane displacement D? If you take a crop canopy of 1 meter height, it is in the crop where the logarithm uniform starts or turbulence starts from the zero ground level. Turbulent won't start at certain height, it starts. That's what we call it as the zero plane displacement D. Now see, if it is vegetation, if it is open field, also the zero plane displacement is not the surface of the earth, it is certain height above that. In other words, this also I read what is roughness parameter. It is a parameter of bit may come like this. It is a parameter of vertical wind profile in equation that model the horizontal wind speed near the ground. In the log wind profile, it is equivalent to the height at which the wind speed theoretically becomes zero. The wind speed is not zero exactly on the surface at certain height because of its roughness. Somewhere the wind speed becomes zero. Similarly, even though the zero plane displacement is also 6 to 20 times higher, at that height also the wind speed becomes zero under peculiar conditions. Please remember, both at D and Z0. D means zero plane displacement. Z0 roughness parameter. These two may add in certain situations where the wind speed theoretically becomes zero. Zero plane displacement is the situation where theoretically wind becomes zero. Roughness parameter is the situation in which the wind speed becomes theoretically zero. These two, Z0 plus D, also is the situation in which the wind speed becomes zero. That means from there only the turbulence starts. So these may come in any form in your bits. That's why I would like to share with you. Thanking you very much for your very patient hearing. We meet in our next class to understand further more bits.